Alright, so we have a difference of cubes right here, x cubed minus a cubed, and I want to factor it. So basically we're going to derive difference of cubes, factorization formula, whatever you want to call it. So yeah, we want to factorize this. Now first, really easy factor is x minus a, right? X minus a, really easy factor, you can see that. And the reason you can see that is because if we set this equal to 0, right, we set this equal to 0, I mean x would obviously be equal to a, which means x minus a would have to be a factor, right? So since we know x minus a is a factor, we can really do a quick synthetic division, right? Put a in the box, right? And now you know how you set it up. Coefficient for the cubic term, that's just 1. For the quadratic term, there's nothing there. For linear term, there's nothing there. For constant, it's negative a cubed, right? Negative a cubed. We'll just do a quick division, right? So drop down that 1. Gotta make sure there's no space. So drop down that 1, right? 1 times a is a, so you got an a here. A times a squared, right? Drop an a squared. A squared times a cubed, right? And these cancel out, so it gives us nothing. Alright, this is expected, a is a factor, we know that. So let's take a look here. Let's take a look at the result. This number is going to be a coefficient for our x squared, for a quadratic term. This is going to be coefficient for our linear term. And this is just going to be our constant. So the full factorization of this would be x minus a, right? Obviously x minus a times, so let's see, 1x squared, right? 1x squared plus ax, right? Plus ax, right? And a squared is just a constant, so plus a squared. Alright? So that's basically a difference of cubes formula. If you know the formula, you know this is correct, right? Because the same sign here, opposite sign here. This one is always positive, right? Same opposite, always positive. So we got the expected result. Derivation pretty quick. Follow for more things like this.